everyone, and welcome. It is Wednesday, and we have a great opportunity to get to know one of our crew members today. I'm not going to tell you who it is just yet, but I want to go out of my way to thank all of our paid supporters on Patreon and YouTube. Your support really makes a difference as we go for the complete non-AI YouTube channel. So with that, I want to introduce one of our crew members who's been so gracious enough to spend his time with us, and also he's going to be sharing his collection with us tonight, and that's Scott McGregor. Scott, welcome to the program.
Hey, thanks, Topher. Good to be here.
Thanks, man. Yeah, we're not going to get into you so much as your history and blood type, shoe size, and that kind of stuff. Okay, so just relax. We're gonna have a little conversation with you, and we want to get to know Scott as the meteorite collector. So Scott, through his collection, what interests him, what floats his boat, what's too boring for him to waste his time with, and what's super interesting that he just can't live without. I know two things in your life that I think will have a hard time living without, if I can be so bold. I'm gonna go and say you have a beautiful wife of over 30 years, and you live in California.
All true.
Okay, and besides that, the only other tidbit of personal information it's so juxtaposed to what we always discuss: rocks, hard, cold, dead. You have another hobby that takes a lot more nurturing and kindness and caring compassion, I would imagine. Do you know what I'm talking about yet, or?
Yeah, when I was a kid, I loved science and everything. So, I had rocks. I wanted to be a geologist when I was a kid. That was what I wanted to grow up and be. And but I had snakes and lizards and plants and all manner of things. And so that evolved into exotic plants, just like I have exotic rocks, meteorites, exotic plants. So I also grow carnivorous plants and tropical orchids. And so it's kind of fun. I've got about 500 orchids outside that grow in the balmy Southern California climate.
Wow, that is so cool. Now, do you get into mixing them and I know the term's not breeding them, but correct me, please.
Hybridizing or propagating. Well, the problem with orchids is that some of them take 10 years from seed until the flower. So that's a long time. Many plants, it's a single season and you see your result, but some of them are a decade wait. So no, I don't do that so much.
Okay. Well, I appreciate you sharing that. It's a unique hobby, taken very seriously, I might add. So, now we're going to talk about what we all came for, man. The dead cold rocks from space. And I'm going to actually allow you to start the conversation, showing off what you want and telling us why. Why, Scott?
So I got interested in meteorites. I loved chemistry when I was a kid, and so I said, why don't I collect all the chemical elements? And so I have 1-inch cubes of most chemical elements that you can get, and that's fun. And then I got into mineral spheres, and then I found out that you could actually get meteorites. And because I was interested in mineral spheres, I got a meteorite sphere. And that was fascinating. And of course, I think I got ripped off on my first one. I think I bought what was supposed to be a Gibeon, and it was like Muna Lustra that was plated with rhodium or something like that. So, the usual eBay kind of oops thing.
A third the value, but at least it's rhodium plated so you can touch it.
A third the value and equal the price. Absolutely. But anyway, I did a little studying after that, and I found it's fascinating. And I think of meteorites, geology and the stuff we study on Earth is one thing, but meteorites are extraterrestrial geology. So it has all the fun of the geology on Earth, but even better, it's about the solar system. And it's amazing, and you guys all know this, it's amazing all the different parts and time periods of the solar system you can collect in meteorites. And so that became fascinating to me. And I tend to, when I'm excited about something, I read everything possible and absorb as much as I possibly can and self-educate. And so I'd say I'm not the level of many of the classifiers and experts you have on the show, but I'd say I know enough to be dangerous now.
Yeah.
So
We're on the fun side of the Dunning-Kruger curve.
yeah, absolutely. So for me, the fun meteorites, I have like 150 or so in my collection, and I'm only going to show half a dozen tonight, so not so many. But the fun part about meteorites for me is if they meet one or preferably all of three criteria. The first,
Oh,
for me, most
interesting.
important one is that they be scientifically interesting. So something about it is important to science, or a new discovery, or something that tells us about the world. The second attribute that I look for is that they're historically important. So many meteorites, maybe they're not scientifically important, but they're famous because of when or where they hit,
Right.
or who found them, or things like that. So that, or the story.
Yeah.
And I don't have any meteorites that I've found myself. Of course, many of you probably have meteorites you found yourself, in which case that would instantly put it at the top of the list for
Yeah.
most interesting. But I don't yet have any of those. And then the third criteria for me is aesthetics. And
Mhm.
so, is it pretty? Is it beautiful?
Yeah.
Is it pleasant to look at? And so, if I can find a meteorite that's scientifically interesting, historically interesting, and beautiful, that's going to
Oh,
get a top slot in my collection. So I've got a few of
man.
those tonight that I think will be fun to show.
Oh, well, that's super interesting. I love the criteria: scientifically important, historically important, and aesthetically pleasing to look at. That that's a easy criteria to meet on one or two occasions, but you have something tonight that we don't do show and tell on webcam, but this one I have no problem with. Your first one that you wanted to show kind of ticks the boxes of all three of those criteria, doesn't it?
So the first one I'm going to show is this little potato here, and I don't know if anybody can sort of recognize what this might be. I'll give a couple hints. It's carbonaceous, and let's see, it's a CM2 actually. It's a CM2, and I would argue this is the scientifically most important meteorite of them all.
Murchison?
Good guess,
A
Pat.
Hyundai?
This is Murchison.
Ah,
And so what I'm going to do is I'm going to go to a screen share now and show this off. Hang on one second here.
It's spectacular because most time when people are showing off their merch, then they have to do a screen share or a microscope share. Not a oh wow.
So what you're looking at here is the side that was facing down, and there's some iridescence on the front here. You can see the cracks. A lot of Murchison is cracked because it had a lot of water and organics in it, and when those evaporate after a little while, it tends to shrink, and so you get some cracks there. Also, as one person pointed out, they don't put pillows out for these things to land on, and so they do tend to hit the ground, and that's a problem. You can see over on the left side there, sort of some little crackling and stuff like that. So some little flow lines. And here's another side picture of it. You can see a little bit of
Oh
shaping
my gosh.
there.
Really see the iridescence in the fusion crust now.
Yeah, and you can see a little bit at the top that goes along there. There's a lip on this as well.
Mhm.
And I'll show one more picture of that. And you can see this is the backside, and you can see the lip that sort of goes around there.
Oh my word, Scott. This is an entirely complete oriented Murchison.
Correct. This is
If you didn't know, I'm sorry.
this is a complete individual and flight marked, and
Wow.
it's kind of fun. And of course, the history of Murchison. I mean, it's sort of an interesting looking rock by itself, but many of you know it. It sort of landed in Australia in 1969. A lot of it landed something like 100 kilograms, but I would say it's probably the most scientifically studied. If you Google Murchison meteorite, you'll find literally hundreds of papers on this. And what's fun about it is it's a CM2, so it's a carbonaceous chondrite, and it has CAIs in it, so from the early days of the solar system. And it has lots of organics in it. And I'm not
Mm.
just talking about benzene and methane and stuff like that. We're talking about amino acids and a lot of the building blocks of life. And they
Yeah.
found 70 different amino acids in Murchison. And some people said, "Oh, well, it's terrestrially contaminated. They couldn't have possibly come from outer space." And it's interesting because all the terrestrial amino acids from life as we know it are all left-handed, and the ones in Murchison are equally left-handed and right-handed. And so that's not terrestrially contaminated. That actually did come from outer space. The thing that makes it even more interesting, and they only discovered this fairly recently, just a few years ago, is that there's some pre-solar grains in this as well. So
Mm,
they've dated some silicon carbide grains in this to 7 billion years. Now that's an interesting number because if you think about our solar system is a little over 4.5 billion years old. And the 7 billion is closer to, the 9 billion when our galaxy was formed.
yeah.
So this is from a long, long time ago. And I would say Murchison or many of the other C2s that might have this, CM2s that might have this, it's like the oldest substance known, and that you could possibly own or touch. So it's a lot of fun there. So anyway,
Wow.
this is a fun meteorite, and it meets the criteria of scientifically interesting, and
Yes.
I think it's
Science.
pretty, and it's got some interesting history, especially with all the
Yes.
things that they've done.
Absolutely. That one's tremendous. Wow. Yeah, I did not think that was going to be Murchison when I first saw that. My guess, I have to be honest, I'll tell the crew and everyone watching, I thought Vinales. I thought it was a Stony. Well, that is really super cool. So
So
I'm going to jump in and say as far as the scientific importance and scientific discoveries siphoned out of these meteorites, I see a recurring thing about time and how old and where in the universe's life cycle that item is from. I think your next item is one that the crew is pretty familiar with. It's a chondrite, and it is a very, very old piece of material.
So the next one I'm going to show is ErgCheck 002, and I think many people are familiar with this one, and I'll go to that here. And this is a fun piece. ErgCheck 002, it's interesting. It was found in Algeria in 2020, and there's like 32 kilograms of this stuff around, so a fair amount. But this is the oldest volcanic material known. So Murchison is like the oldest material around, and this is the oldest volcanic material. And this came from a protoplanet that was a chondritic protoplanet, meaning that the same material that makes chondrites and stuff formed a planet, and it got large enough and big enough to have volcanic activity on it and magma. And as the magma flowed, it slowly crystallized. And what you see in EarthCheck 002 are these beautiful green crystals in it of various sizes. And uh, that's quite pretty. They're pyroxene crystals, and they're pretty green in this. And what makes them green is there's an unusual amount of chromium in EarthCheck 002, which is different than Earth magma, which is generally not chromium rich. And so you don't get quite this pretty green color in pyroxene on Earth, but in EarthCheck 002. And what I love about this piece, it's sliced fairly thin. And the nice thing about when it's sliced fairly thin, and you see that sort of big crystal running through the middle of it there. And if you backlight it, you
Oh
can see
yeah.
that it is indeed transparent on that. So this is a fun one. So this meets the criteria: oldest volcanic material known in the solar
Mhm.
system. And I think it's pretty as well. So it
Oh, it's
scores well.
stunning.
Not so much on history, but that's okay. It's pretty.
Well, it's rewriting the books of what we expect meteorites to be. And so it could be historic, and if you just give it a few years. That one is absolutely tremendous. Having that huge crystal in there is very, very rare. Yeah. And
It was fun. I have another piece of it, and the crystals are not as distinct and pretty. And I went to the Tucson show, and I went into Mike Farmer's booth, and this was sitting there, and so we had a little conversation. And the good news is I walked out with it.
yeah, we'll end it with that cliffhanger. I think it's also very interesting that you chose two items on opposite ends of the spectrum. As you said, I'll just reword it for my own understanding as well. The carbonaceous material, the Murchison, existed before our sun and has remained unaltered, unchanged. It fell to Earth and was collected immediately for meteoritic terms and has been studied at length. This other one, this material went through the chondritic phase, through differentiation, through its own geological processes on a protoplanet that doesn't even exist anymore because it got obliterated.
Absolutely. In fact, it's 20 million years older than the Earth. So it got obliterated like 20 million years before the Earth coalesced. So there was a lot going on in the solar system before our current set of planets.
Yeah, yeah.
There were quite a few. I don't know what the number is. It's like dozens of planets used to exist,
Mhm.
and the number got shortened. So
Yeah, thank you, Jupiter. Um, go ahead. Do you want to? If you have something else to add, add it. If not, we're ready for a sedimentary meteorite.
correct. So the first two meteorites are both older than the Earth. I'm going to show one more meteorite that's older than the Earth, and this is Ishievo. And Ishievo is the oldest sedimentary material known. It was formed about the same time as the CAIs, or shortly after the CAIs. So it's very early in the formation of the solar system. Ishievo is interesting because it has these layers in it. And if you look at this, you see those lines sort of running across it. And what happened with Ishievo, it's a bencubinite, by the way. It is classified as a CH slash CBA, CBB, sorry. So it's a bencubinite as well as a high metal chondrite. And the metal and the chondrules coalesced over time, and they believe that this passed through plumes of metals and chondrules, and they accreted onto this body. And so
Wow.
that's how you get the layers in this. And it's fascinating because if you look at this closely, you do see the different layers over time as they
Yeah.
came on. And it's nice if you have a larger piece of this. But another thing fascinating about Ishievo is that it also has in the chondrules, intermixed with them, it has some interesting things. And so this is a close-up of the chondrules in it. And you can notice, first of all, they're interesting different color chondrules. But right in the dead center of this, you'll notice there's a very interesting colored object, and
Yeah.
that's hibonite. And hibonite is a rare material. It's very rare on Earth, but it's somewhat common in meteorites. That actual hibonite is maybe, 2 millimeters across. So it's not particularly large. But if any of you have Ishievo, I highly recommend you take a loop, a 10x loop, and go out in the bright sun and go look in the chondral areas of Ishievo and see if you have any hibonite. But this is a fun one because I think it's way underappreciated
Mhm.
given how old it is. It's a single classification. It's got lots of stuff going on. In fact, Lawrence Garvey at ASU was interviewed, and he said this is his favorite meteorite.
Yeah.
And he has a lot to choose from. So quite interesting there. It is also seen in some other meteorites. If you see this sort of bright blue color, hibonite, it's kind of fun. So this one, scientifically interesting. Um, it's pretty not so much on the history side, but I think it's well worthy in the collection.
And I think you hit the nail on the head when you said with that one. I mean, obviously, bigger is always better, but with this one in particular, bigger is better because you're looking for those layers. You're looking for everything in there, not just a tiny little swatch. Looking at it with binoculars, as I call it. You wouldn't expect. I didn't expect to when you zoom into it to see so many silicates because when you're zoomed out holding it and in the first picture, it looks like it's 95%, 99% iron. Looks like a regular, slice of an iron meteorite.
Well, you're right. And the fun thing is that because it has the sedimentary areas in it, you look in those stripes across it, and you'll find some that have a lot of chondrites in it, and others are mostly metal. So it's not uniform across it. The chondrites are definitely in bands. And of course, I chose a high chondrite band to zoom in on. So that's
Yeah.
why.
You went in Rome. Well, that's really interesting. And that talks to another evolved planetoid that went through the differentiation process and isn't pristine, obviously, because we have the mixture of it. Um, I think this may be the final one for the show and tell. And this is an absolutely, if someone doesn't say this is beautiful, even not being into meteorites, they'll need to get their eyes checked.
So this one I think rings the bell for scientifically interesting, historically interesting, and pretty at the same time. So this is Krasnoyarsk, and Krasnoyarsk is a palisite. And let me go to screen share, and I'll say a little more about it.
And I think it's interesting too that when you started collecting items, you were collecting elements and the element cubes. And so the elements and what's actually in there, the chemistry is important and something that fascinates you. And you can still follow even the tiny little hibonite crystals. You can find them and study them and enjoy them in meteorites as well.
Well, meteorites, as you know, have so much stuff going on. They have quite a variety of chemistry and physics and just geology. It's a lot of fun. Krasnoyarsk is a really interesting meteorite. It's not older than the Earth, like the other three. It's a palisite from the main group, so in the asteroid belt. And it was found a long time ago. So this one was found in 1749. So this meteorite was found almost 300 years ago, so a long time. And it was found by a blacksmith, and they dug it out of the farm field, and they noticed that when they hit it with their hammer, it had a ringtone as opposed to the usual thud of a rock or something like that. And they thought, wow, this is interesting. And there was an academician in the area. His name was Professor Peter S. Pallas. And he saw this and he went, "Oh my God, this is interesting." And they cut some pieces off of it. And he noticed that this was really unusual. And they sent it in and they had quite a study on it. And they ended up naming the category of pallasites after Professor Pallas and this meteorite. So this is the original classification stone for the pallasite group, and it has a number of interesting properties. It certainly has pretty olivines in it. And it was fun because when I got this and acquired it, there's different tastes in pallasites. Some people like them etched, some people don't like them etched. So you'll find some pallasites on the market that are polished on both sides, etched on both sides. My personal preference is etched on one side, polished on the other side, because then you can decide, which side you want to look at. What's fun though is when I first got this, it was polished on both sides. And you say, well, okay, that's okay. You could just leave it that way. But I absolutely could not leave this one polished on both
Yes.
sides. And let me tell you why. Not only was this the original palisite that defined the palisite group, but this was the first meteorite to be etched with acid by G. Thompson and to show Widmanstätten patterns. So this is the very first meteorite that revealed Widmanstätten patterns to the human eye.
Hmm.
So my God, how can you possibly have
Yeah.
the first meteorite that had Widmanstätten patterns to have them
Polished.
fall away? Oh my God. So that's why, of course, it's etched. Now it's etched on one side. And here
Oh
you can
man.
see it. Here you can see it in the sunlight. So I would say this one, it's historically important. It's scientifically interesting because of the discovery of
Yes.
Widmanstätten patterns, and I think it's really pretty. So
If you could, Scott, I'm not going to argue with you any of those facts. I agree 100%. Leave this on screen for a second because I think well done. Well done. Picking out examples and explaining they meet your criteria trifecta. As you explained on this one, the significance of the Widmanstätten pattern being discovered in it, just the beauty of it, and the I always enjoy the violence of the olivines. But on this one at 1 o'clock, you have a missing olivine that I think if you had to press, I would say adds to the beauty of this piece because the olivine is missing, but you have that center post of metal that would be coming through the olivine with the back support fully visible. I think that is a unique characteristic among all the other things you mentioned about this piece.
well, thanks, Topher. And there's one other interesting twist of irony. This is the original palisite from which the palisite group was defined. Do you know what this is classified right now? It's classified as palisite main group anomalous. And I just think it's really ironic that the palisite that defined the group is anomalous. It should be all the rest that are
Yeah.
anomalous. This is the one that isn't, but this is an anomalous classification. So a sort of cruel irony in that.
Yeah,
That's really cool. Thank you for sharing that. That's really, really cool.
I want to close this part by saying my thanks as well, Scott. I appreciate you every week supporting the crew, and I appreciate you allowing us to dig a little deeper into you personally, getting to know you through your collection, and explain to us there's so many meteorites. Like these spoke to you on a certain level, and they keep speaking to you on those. And those three things are I think are super cool: aesthetically beautiful, scientifically important, and historically important. So I'm going to challenge everyone to look through your collections and find what tick marks your collection ticks and what it says about you. Scott, thank you so much for your time. Really appreciate it today.
Thanks.
Everyone on YouTube, thanks for watching and have a great evening, guys.